All right. Well, welcome everybody. This is the wire repair fundamentals, the best practices. Do want to welcome you all. Thank you for tuning in today. I am Larry Rambeaux, sales application engineer with Purkeys. Been with the company for a little over 34 years. Cover all the U.S. And with me today is our Tim Campbell. He is our product or project manager. He's been with us for over 3 years now. Covers a lot of the U.S. as well. Does a lot of the special projects, new products, etc. So we're going to take turns kind of bouncing back and forth, covering a lot of this. One of the first things I want to say, this is not going to make you an expert on wire repairs in one day, in 1 hour for that matter. But do want to, show some of the important things to look for. The whole thing is, there's always going to be wire repairs in the trucking industry. But what are some practices, some rules, some, suggestions to help make sure you make quality repairs that are going to last? We always talk about those side of the road repairs or whatever, but no matter what, if we're going to make a wire repair, we have to use the right tools, the right products to make sure that repair is going to last. So I'm going to let Tim kick it off and go over some of our first slides.
Perfect. Thank you, Larry. Thanks for that intro. And yeah, let's jump in. First up, we want to cover preventative maintenance and talk specifically about visual inspections. That's going to really help you pinpoint, especially if you're troubleshooting, be able to see some really good spots to start here. Here's one that we see all too often in the field, which would be just signs of previous repair. Here's a really good one up at the front of the trailer. And of course, you really want to watch for the current carrying cables, anything that's flowing a good amount of amperage. That's something that needs to be inspected pretty close. Make sure that that wire integrity is still good, that you have all of your copper strands, you're not missing half of them. And as you can see in the picture, probably someone backed up a little bit too high, pinched it, and I don't think I'd consider that a proper wire repair with electrical tape. Who knows what's under it? Could be proper, maybe not, but it's not looking great. The fact that there's no split loom conduit covering those exposed wires makes me think that this is more of a Band-Aid than a permanent repair.
Well, my thing, Tim, is if you got a spot that looks like an anaconda that swallowed a goat, there's a problem in there.
It's a great point. And here's one that we unfortunately still see out there every now and then. These pictures, if I recall, Larry, you said these were off of new installations, correct?
Yes, this was kind of pilots, after company took new trailers in, kind of went and did inspections on them. And yeah, these were all things we found on, basically new installs.
Yeah, and one thing that I see on all of these is exposed copper. And anytime that you're having exposed copper in this environment, that's going to sooner or later lead to a degraded connection. The corrosion is going to go into there. Purkeys does provide heat shrink for all of these locations. The main harness is a cut to length harness, depending on where the battery box is mounted and the trailer configuration. So we do rely on the upfitter to make these connections. You can see on the left, there's no heat shrink over those crimped connections. Exposed copper down underneath those ring terminals. And our main 4-conductor harness in that center picture, you can see that when they were stripping the outer jacketing, went just a little bit too deep and sacrificed the individual wire jacketing. You can see the copper showing through there. Purkeys does include a piece of heat shrink with adhesive fill for that location too, in case something like this happens. Was not used in that application in the middle picture. And on the right, looks well-intentioned, but looks like the heat shrink got a little too tight and actually pulled itself open. So they've used the heat shrink, but now you still have exposed copper. And of course, the the heart of the entire 12-volt system, batteries here. Make sure that you have good, tight connections. Crazy to see a connection like that. And even the terminal stack, it looks like you have a lower, smaller gauge wire stacked somewhere in the middle or even down at the bottom of this terminal stack. You always want your higher power, higher amperage cables closest to the battery and stack up from there.
That is a great point, Tim.
And here's a wild one. I don't know who captured this photo, but obviously, if your terminals are turning green, time to clean those up. And I'd say that this is probably one that we see most common out there. Even if everything else is done right, it's, I won't say a 50-50 on this, but on top of making sure that the battery nuts are properly torqued and that terminal stack, you should always, best practice is always have any loads that are connected to the battery, those should be staggered. So have your positive on one battery, negative on the other, and that goes the same for charging. That really ensures that the batteries receive even wear throughout their lifetime. And we see it all too often where the installer just connects to one battery and calls it a day. And of course, here is a, actually, the first thing that catches my eye in this picture is the mismatched batteries. That's usually never a good sign. But one thing that we do come across as well, if the PMs aren't done often enough, and if it's just not done correctly, these battery hold downs, I think that we've all seen them, the batteries just bouncing around inside of the battery box, and a loose hold down bracket. I've seen them extremely loose before, where it's almost borderline sliding all the way up and grounding out on those positive terminals, which would probably be a really good fireworks show, but not so great for your batteries. And of course, just any excess vibration of the batteries, that's really taking away from their service life. So next up, here's our first poll question, and we'll ask the audience. It'll be a great poll for the audience, kind of see what all your peers in the industry are doing for wiring preventative maintenance. So the question is, how often are you doing preventative maintenance on your wiring? Are you doing it often, sometimes, every time the truck gets a PM, or never? We'll give
And
a little
honest,
bit for some.
We can't see who answers what, so please be honest of what your standard practices within your organization.
Yeah, and if anything, hopefully by the end of this webinar, this gives you some really good points to look at and add this into your PMs a little more often. All right, we got a pretty good amount of answers rolling in. We'll give it just another second here. All right. And how about we look at the poll results? We'll see how our industry peers are doing their PMs. Ooh, big fan of that. Looks like top 70% every time the truck gets a PM, doing a wiring PM as well. And no one said never, so that keeps my faith in everyone here. Thank you, guys. And with that said, yeah, I'd like to turn it over to Larry for the next section of repairing what we find out there in the field. Larry?
All right. Thank you, Tim. Great information on all that. First you got to take a look at it and find it. And the other thing is, when you're doing that, is look for common areas. It's like, hey, I've looked at 3 lift gates or 4 air conditioning harnesses or headlight harnesses. If you're seeing something that's a common one, you may want to get more proactive, figure out a way to fix it, or better wire retention, which we're going to talk about some in some of the RPs and stuff. But yeah, be more proactive. Don't wait for it to break. And some of those too is make sure you bring that up to your liftgate, trailer, truck OEM. So going forward, says, hey, next time we build trucks, we got to do something different here, because we're having all kinds of issues on existing trucks, or again, trailers, liftgates, whatever. One of the first things I do want to talk about is I'd like to think we're very good at what we do and all these things, but we didn't come up with all this stuff. A lot of the people I see on the attendee roster here today, knowing the industry, bigger fleets are involved, is we have TMC, the Technology and Maintenance Council, that their work in the industry is to write documents or recommended procedures either for proper repair or proper inspection, or even on an engineering side, the proper way to a truck or whatever should be built from the get-go. So there's a lot of good information. That's where we gather a lot of, our practices is from these different RPs. So you're gonna see a lot of information here, and some of it may be Greek to you. But if you have questions, again, reach out, send messages, and we can get you, copies of some of these. But encourage you to get involved in TMC to help the industry on all these things. But a couple of what we're going to talk about right off is the engineering recommended practice is 105D. It's a design and installation. Now, what is the proper way to do all these things? I mean, there's RPs on proper fusing, circuit breakers, the right types of wires, the right repairs. So again, a lot of this information is recycled from that we use. But just wire and cable repair guidelines. It covers what type of wire, how do you route it? How do you do this? How do you do that? So some great information. There's links at the end. We'll go over in a little bit more detail. But just a wealth of good information that want to make sure people are aware of. And a lot of times, talking to fleets that, some of the practices they have in their shop, came from these RPs, and people don't even realize where that information came from. But before you begin, you got to make sure you have the right tools. And just like anything else, proper testing, proper diagnosis is you got to use a meter. I don't care how much you paid for your test light. It's still a test light. A meter is going to flat talk to you and allow you to do a lot of these tests a lot more detail. But you have to have the right crimpers, the right stripping tools, the right, heat guns. And one of the biggest things is the right terminals. And one thing you have to keep in mind when we talk about right terminals and right tools is a lot of times manufacturers, have their set of crimpers that are designed for their set of terminals. And there is no, one size fits all. And we see that in, different repairs, you could very easily tell someone did not use the right type of crimpers on the terminal they were working on. So make sure what you have. A couple other safety things is make sure you disconnect power before you're trying to work on it. Yes, it should be fused, should be protected, but you don't want to do any damage. Buy a lot of fuses trying to do a repair. So make sure you are disconnecting power first. But yeah, what are you working on? What am I working with? Is it a bad crimp? Those are things we see a lot of times. First, you see that larger cable in the picture there. And also the picture Tim was talking about earlier, the battery lug that was very corroded. If you notice, both of those were bare copper lugs. Copper obviously is the best economical, material to use for repairs, but I highly always recommend you make sure you're buying tin plated ones. That has a huge impact on that, how much corrosion they're going to get. Is it corroded? Can you clean them? One of the things we talk about OEMs is nobody ever gives you more cable than you need. So if you're working on that truck, reefer, liftgate, whatever, and you start to see degradation, corrosion, whatever, if you don't fix it now and you allow that corrosion, you see the picture on the right that's been exposed and it's had all kinds of wicking, acid or whatever going up in that cable, that it gets to the point that you can't even cut it back far enough to make a repair. On some of today's modern trucks is, I know one truck OEM on the battery cables, if you have to repair them or replace them properly with all the cables and clamps and zip ties and everything that it left the factory with, that can be like a 10-hour job. So make sure you take the time and look at all of it, fix it before it becomes a huge issue. Spliced wires, you see some crazy things people have done in the field. That's wire nuts have no business on a vehicle. People twisting things together, wrapping with electrical tape. Again, some of those things we're going to go through later on in the presentation. But is it a fresh install? I'm not doing a repair. I'm hooking something up the first time. All those things to take a look at. Talk about primary wire. make sure you look at your wire. There is tons of differences in wire. You can't just go to your shop's rack of wire if you have one and assume it's all great. We see people using house wiring. It's got a totally different insulation. What is the voltage rating? The wire type, the wall thickness, especially when you start getting into different types of connector bodies. There's tons of different manufacturers out there. Obviously, there's Delphi, there's Amp, there's Deutsch, JAE. Some of those require a thin wall type wiring to meet the right requirements for their seals. Temperature rating is one of the biggest things that you should make sure you're stocking for all your shops is the right temperature rating. Spec it should be at least up to 125 C. Wire size. I go to shops at times and they got big wire and small wire. There's more than two options out there. The other thing too is make sure you're replacing or repairing with the correct color. You want to make sure the poor next guy that has to work on that vehicle is not trying to troubleshoot a wire that's blue on one end and purple on the other end. Just some more information here. This is information again taken from TMC. What some of those different recommendations and numbers are, and we talk about things that aren't recommended. And usually, what you see in the shop is a GPT or general purpose wire. That may be fine for your lawnmower trailer, but when we get into trucks, you definitely do not want to use it. One of the biggest things that is an issue is the fact it will reflow if it gets hot. When I say reflow, is that wire or that insulation will actually just melt and come off the wire. When you get into your GPTs, those are thermal set plastics. Makes a huge difference in the end result when you do have a short or something. Again, get with your manufacturer. Make sure you're using SAE certified. Don't be buying cheap wire, especially when you get into recycled copper. That can be a huge no-no on how that wire is going to perform. Again, same color, same circuit identification, cross-link. All those things are very important to make sure you're using the right stuff. I'm going to turn it back over to Tim now and talk about terminals.
Yeah, perfect. And this really builds on what you covered a little bit there, Larry. Again, just bad crimps, and we'll talk a little bit more on this towards the end, but just not having the proper tools. I see so many folks that just have, some Harbor Freight crimpers, which is fine if they're the right tool for the job, but a lot of times it's just the cheapest thing that came with their cheapest terminal set, and they've just held on to them forever. Never really went and did the research on the proper tools for the job. It really goes for anything past wiring as well. Just because you have something that can do the job, does that mean that it should be doing the job? And same thing with soldering. It is something that does have to be learned, but you have to make sure that all of your materials are up to temp and you're getting a good solder flow when you're using solder. And of course, I think number one with all of this is just not using heat shrink as well. That's your number one protectant against corrosion. And like some of the pictures that Larry showed, that corrosion does wick up into the harness. The longer that it's there, the further up it goes, and you'll end up getting some crazy voltage drops and some real phantom issues when you're trying to track down whatever's going on with your equipment.
One thing I do want to add, Tim, there is solder is very, very important, but make sure you're using the proper solder. There's rosin core solder and there's acid core. Acid core is what you use if you're soldering pipes or something. Rosin core is what you need for electronics.
Yep. And here on terminals, again, Larry covered a little bit of the intro on this, but just making sure that you have the correct terminals for the job. We've seen it a couple times, even just with our standard liftgate charging harness, where there's an 8-gauge cable in there, and a lot of times people will have a 10 to 12 gauge ring terminal and try to fit that onto an 8-gauge wire, and you'll see half of the copper strands are just left out of that connection. It's kind of makes it little ridiculous to even use a big wire if you're going to shove it into a small ring terminal at that point. And second bullet point here is really important. We'll get into that a little bit more later, but insulated terminals really make it difficult to get a proper crimp. You're not just crimping the metal onto the copper conductors there. Now you're having to crimp through a insulating material, and really you're not going to get a good visual to see if you have a good crimp underneath that insulating material. Again, we'll get into that a little bit more on some of the future slides, but yeah, I'm not going to talk too much on it here. I don't want to spoil it for you guys. And here we go, the types of terminals that we see out there. Of course, the one with the big red X through it. These are the ones that you get in your dollar store bin of terminals. Anything with the vinyl coated terminals, really, really bad for this application. Honestly, I can't think of an application where I would feel comfortable using those. I would say number one preferred, and going to turn it over to Larry in a second. You'll see why. But on the left, the non-insulated terminals are always going to be preferred. That way you can see that you have a good crimp. You can see the wires are in all the way. And we'll get into why the nylon heat shrink and the solder sleeves are a little bit more hit and miss than using just a standard non-insulated with heat shrink. Oh, and I think that we have a question that came in here. Is soldering a crimped terminal recommended, or is that overkill? Larry, do you want to touch on that?
Yes. My humble suggestion, I would try to solder anything I can. Just like Tim was talking about the different terminals here on the screen right now. That's one of the biggest reasons I like the non-insulated, that you can crimp them. You can visually see how well you did on that crimp. Gives you a good opportunity to solder it, especially anything that's going to be exposed to the elements. Even liftgate, most liftgate manufacturers have, a fairly well enclosed box. There's still a lot of contaminants that can get into that battery box. It's going to cause corrosion. So my humble opinion, yes, I would solder everything I could. And then again, do that a quality dual wall heat shrink over it. And we talk about some of these other terminals that are on the screen right now too, like the nylon heat shrink type terminals. Those are definitely better than the vinyl coated. I am still not a huge fan because, again, I would still rather solder it. Number two is a lot of times people don't use the right crimpers on them, and they wind up either not getting a good crimp, and you can't see it because of the heat shrink over it. They pierce them, so you still wind up with an unsealed connector. And the other thing is when you pay for those, that's the non-insulated ones, for most of the, nut, bolt, screw, supply, or whatever, are pennies. The nylon heat shrink and the solder sleeve ones, you can be looking at over $1 a terminal, versus, again, pennies for the bare ones and a couple more pennies for some good heat shrink. It's much cheaper and a much better connection. The solder sleeve ones on the far right, I am not a fan of those at all. The reason why is generally those use a very low temperature solder inside of them, and you don't ever get the wire hot enough to really get a good solder connection. And again, you want to talk about expensive. Those are very expensive for that. And a lot of times I don't even see people ever heat shrinking these ones anyway. So yes, solder everything you can. And again, I would still always go with bare. One thing we were talking about battery cable before too, I wanted to stress is when you're soldering something, you should heat it and let that the heat suck the solder into the connection. That whether it's a little terminal spade or an eyelet or whatever, that when you're soldering, you kind of get used to doing it. You apply the solder, you'll see it sucking and it fills up all the voids. Same thing if you're doing a battery cable, talking 4-gauge, 6-gauge, 1-aught, 2-aught, whatever, that if you apply heat to it, and it's going to take a while because that's a lot of material trying to heat, but once you do and you apply solder, it will suck in and fill all those voids. I see people, and I even see a lot on, I'm a car guy and I watch a lot of the car shows. You'll see people that will put a copper lug in a vise, heat it up, fill it full of solder, and then shove the cable into it and don't even crimp it. Yes, the solder was hot, the lug was hot, but you never got that cable anywhere near hot enough to get a good connection. So that's probably one of the biggest fouls I see. And one of the slides Tim showed before, I'm going to back up here a little bit, is if you notice on this one, the biggest party foul is that cable lug that they put on. I think it's a 4-gauge cable, and they use like a 1/0 or a 2/0 lug. There's no way you're ever going to get a proper connection. No crimpers can go down and do that correctly. So make sure you're using the right ones. I was at a large fleet years ago and had to replace an end on one of the battery cables. Cut the end off, got it all stripped back, and asked the guys, hey, where's your lugs? And he showed me a drawer, and there weren't any of the right size. And I said, sir, there's no, I'm gonna say, it was a 3/0 cable because I remember the truck now. It was a 3/0 cable, and I said, sir, you only have 2/0 lugs in here. Oh, we just cut threads off or strands off until it fits. It's like, how many problems can we ask for when doing one repair? So again, right tools, right material to do a repair. Sorry, Jim, I totally sidetracked all that.
No, I figured that, it was excellent. And it's a great segue into, I'm going to pass it over to you if you want to continue. You talked a lot about the some of the issues that you see with some of those. And I think that this next section shows exactly a good visual of what you were seeing.
All right. Yes, thank you. We're going to talk about wire repair stress testing. And this is going to be a little bit of an eye chart for you. There's a lot of pictures on these next several slides. So, slide your chair up closer to your computer screen. That one of the biggest things people say, well, I use these and, never seem to have a problem or whatever. Well, I've tried these, or they see it every day on a repair and they don't fix it. So we actually have a salt spray booth here. So we can put in, whatever device or product, whatever, and we can do, long-term testing of what something would see in real world. So we did a bunch of these different types of repairs, tested them, and then ran them through a salt spray test, and then retested them. That quote unquote, yes, they all work when you first do them, but how is it going to function after it's been on the vehicle for 100,000, 200,000 miles or 2 or 3 years? So the first one is, and I'm not going to cover all these in great detail, but most basic repair is just stripping the wire back, twisting it together, soldering it, and heat shrinking it. And if you look at the test we did, we ran a 10 amp load through it and did a voltage drop, and you can't see the whole thing. Is a piece of wire, had eyelets on both ends, and different repairs in the middle. Ran 10 amps through it and did a voltage drop from the beginning to the end of that wire. But if you look, even after going through that salt spray, that yes, it lost some, no matter what it's going to, but was fairly minimal. The bad thing is, that's a good way to do a repair. Most technicians don't do it properly. They don't get it clean. They wind up with a kind of a ball of wire, so it doesn't seal nearly as well. So yes, it works. A lot of times it's very hard to do consistently in the field. So the one on the right is, again, what we're talking about, using a bare butt connector, crimping, soldering. Again, very good service life. But now we're going to get into a bunch of the different connectors that people try to use in the field. Even doing them bare, and then also coating them with different types of, like a rubberized coating, something to give them some more environmental protection. Again, when they're brand new, it's not a bad connection. The problem is after they go through that salt spray, we couldn't even test some of these because they got so bad. And again, that salt spray test is to mimic how those wires are going to live in the field. Wire nuts, again, great for house wiring, should never be used on a vehicle. The taps, very similar to a Scotch lock, but the bad thing is you're cutting strands generally whenever you use these, so they're not a great connection from the get-go, and of course they're only going to get much worse as they are in the field. And again, some of you are going to have questions. Ooh, I want to see that, or I want to take that and show my boss or whatever. Keep in mind that tomorrow you will get a link to the recording of this. Completely exposed, even with protection on them. Again, look at the amount of corrosion on them. Another one was a twist where we did a Y-type connection. Again, some degradation, but not a huge amount. Some of the nylon, butt connectors. Electrical tape has no place. But the only thing I'd ever use electrical tape for is to secure split loom on a wire. But it should never be used to protect a wire. It's amazing what that salt spray can do as it wicks into terminals. If you look at connection 11 on the right side, that was a factory solder type connector, or sorry, heat shrink type connector. That when it was done and weatherproof, it did all right, but there's still a lot more voltage drop than you compare it to the bare butt that we did before. Non-sealed, some of that too is just these are very poorly crimped. If you look at 13, the wrong type of crimpers were used and it pierced it. So even though it was a heat shrink type terminal, that protection went out the window, and you could see where that heavy green is right there where that wire was pierced. Non-sealed butt, even in trying to do rubber coatings over it, huge difference under that 10 amp load. That I went from 0.2 of a volt drop all the way up to 0.7, 10 amps, and if 25 amp was well over 1 volt. Again, the famous wire nuts. Crimp. So again, some of these get a little redundant, so I don't want to spend forever going over them. But bottom line is none of these were ever designed to be a long-term solution. And whether it's a in-house repair that caused this or a outside vendor did it, and that's one of the worst things that all fleets in America are fighting is roadside repairs. One of the things that if you ever want to fix those issues is anytime that a vehicle is in that Billy Bob's trailer repair or whatever, someone needs to flag it next time it comes in. Hey, we're going to look and see what Billy Bob did. We're going to make sure we repair it right so it doesn't become a repeat failure. That doesn't always happen, so something gets repaired over and over when it could have been prevented by doing it correctly the first time. And Tim and I were talking before we started today that I'll get someone that'll make a comment about, liftgate was, broken on the side of the road or had a breakdown on the side of the road. And I said, really? It was like, how did a liftgate have a breakdown on the side of the road? Well, it was stuck down. It's like, wait a minute, why was a liftgate down on the side of the road? He said, well, okay, so maybe it wasn't on the side of the road. But, people a lot of times will defend these poor repairs because it was a time constraint or it was, a safety concern. Completely understand we're all forced to do things we don't normally want to do, but we do have to make sure we get that vehicle back in and do a repair on to make sure it is going to be a long-term repair. The next things,
yep.
I'm turning this actually back over to Tim now, and he's going to talk about when to repair, when to replace.
Yeah, no, that's perfect. And yeah, just as Larry said, just always be on the lookout for any temporary repairs. It's very quick that those temporary repairs turn into permanent repairs until it piles up into a much bigger issue. Now, when to repair or replace, kind of going back through the pictures that Larry was showing, anything a real quick giveaway is anytime that you see the green fuzz growing, that corrosion, that copper corrosion, that's a key sign that it needs to be repaired at that point. And one thing when it comes to repairing any of those connections that do show corrosion on a previous repair, you have to keep cutting back on that wire until you do find that clean copper. And sometimes that gets tough and you end up having to put in a longer wire in between to find that clean copper. But it also goes to show that doing it right the first time saves you from that headache. So running down the three bullet points here, of course, any time that you see the broken or twisted on a repair, get it out of there, do it the right way. The bad crimps are eventually going to cause issues down the line. Get that out, do it the right way. And when you're replacing a cable, of course, just make sure that all of the ends of that cable are properly terminated and get you a long service life out of that repair. And next up, we'll run into a quick poll question here, running off of the TMC, the Technology Maintenance Council. A lot of recommended practices out there, and we talked about it earlier. We'll see who is paying attention. Which RP covers the battery cables, terminals, heat shielding, grounding techniques, wire gauge, and replacement wire selection? 4 choices up there. And again, we doesn't show who's clicking what, but it'd be good to see if anyone was really eagle-eyed on this one.
And just a reminder too that if anyone is having any type of technical issues, make sure you use that F5 to reboot. If it's a sound or anything, or sound quality or lagging, that F5 function should reset everything and fix you.
All right, and looking like we have a pretty good amount of answers coming in. Let's see how we did. Oh, we got a overwhelming support on 105D. And top of my head, Larry is on the study group one for electrical, so he probably knows all of these off the top of his head. But yeah, out of the thousands that are out there.
Yeah, that's what I'm saying. Which one is that? I know RP129 is voltage draw, but yeah, 105 should be all your wiring covers. And there's, we talked about before, and we're going to go over some more here at the end. So many of these RPs also have some overlap of, yes, it's wire repair, but then there's another one that's wire selection. There's one that's primary wire selection. So yeah, that just kind of made me scratch my head. It's like, which one is it? But yes, 105D, that is correct.
Excellent. And yeah, here we'll keep running through. And again, as we mentioned earlier, proper tool for the job. You can see what a recommended crimper would likely look like on the left. Again, this isn't a catch-all for every terminal that you're crimping. But the ones that we still see floating around some of these shops on the right, these are your dollar store crimpers, or the ones that you get from Home Depot in that $5 kit. These are just, please upgrade your crimpers. It's going to save you a lot in the long run, making sure that these are properly crimped mechanically. And if you are using any insulated terminals instead of the bare non-insulated ones, make sure that you're not piercing that insulation. And using a heat shrink terminal, you pierce that insulation, you might as well throw it away.
Yeah, and one thing for, if you go back one, yeah, thank you, Tim. It is a huge ask for technicians to buy a lot of these crimpers. That's one of those things, depending upon the size of the fleet, that may be something that you need to look at the fleet supplying, some of these dedicated tools. Some of the Deutsch crimpers, for example, I have a personal set. They're $600. Did I pay $600? No, I got lucky and I found them at a flea market one day. But I still gave $100 for them. And when you start looking at all these different manufacturers, it can be a huge outlay of money to buy them all. There's certain ones that I think every shop ought to have. or every technician ought to have because they're pretty common. But yeah, you get in some of the specialty ones, that can be a huge outlay. The ones, the figure 20A, 20B, there are some companies that make some that have replacement jaws. So they do multiple different brands or types. And you can still wind up, pretty good amount of money in them. But yeah, 1,000%, the tools on the right, they have no business in a professional technician's toolbox. They're not going to do good crimps. They're not going to do good stripping of insulation. They're definitely not going to do good crimps.
Yeah, well, especially as vehicles get a little bit more and more smart as the years goes on, all the communications lines, any extra resistance in those lines from bad crimp, or if you're repinning a connector, you don't have the connector manufacturer's specific crimpers, you're really sacrificing and running on hopes and prayers that it works.
Yeah, and one other thing with that is a lot of times, well, I'm only a trailer tech. It's like, well, you're still a technician. And yes, trailers are very basic compared to trucks, but we are very close to having CAN bus on trailers. And now you're going to have all those specialty connectors, just like you do on an engine or, inside of a tractor, that are going to be on trailers. So it's going to have to be just as good.
Yeah, it certainly takes a bit of extra research compared to 20, 30 years ago, but it's part of the industry. You have to keep up on it. Next up, this is a really good cross section here. I love this picture that shows a good crimp example. I'll let you guys look through it a little bit here, but just seeing that all of the copper, there's very, very little air gap in there, and the copper is really pushing itself into the lug. The lug's pushing itself into the copper. The wire itself is kind of pushed into that honeycomb form instead of if you just cut a copper strand, it would be perfectly round. This shows that those did all have the pressure applied. Right there in the very top center in the yellow, you can see that you're not having wires popping out through the top. It's a really good example of a textbook crimp here.
And that's a double D, which is, if you would go up one slide, the figure 20C, those are Delphi crimpers or Packard or, AC Delco, depends, how long you've been in the industry, what name you want to use. But those are really good for a lot of your basic double D crimps. When I say, double D, is it, it starts off as a valley, and it, like if you'll go back to the crimp picture, it folds those over back down into itself. And yes, it does a great job. I even use those on like the bare butt connectors because they do such a great job of compressing the terminal.
And on from that to spliced wires. Again, just having an easy fix without having to replace a lot of the cable. You can do it just with the bare wire or with the butt connectors, kind of like what we were showing earlier on in those pictures. And it's really one of the best ways to get a set of wires connected, the most reliable. And insulated terminals, which I think that Larry and I's feelings on those at this point. It's just it's kind of tough to make sure that you're getting that good crimp underneath, that you're not piercing the insulation on the outside of that terminal. But using the correct crimper for those, it's way too easy. In the pictures Larry was showing, you have the expensive heat shrink terminal, and then you end up piercing the heat shrink because you use the incorrect crimpers. And like Larry said in the just a second ago, you do have some crimpers that have interchangeable jaws, where one will be for insulated, one for non-insulated. It's it's a lot more than just squeezing the connector and hoping that the wires stay in. And kind of recycling this picture, because this is just a great example of, hey, I don't have a butt connector. Feel free, twist the wires together, make sure that they're clean, strip far enough back, slide over some heat shrink far enough down, and heat those wires up so that it melts the solder, wicks the solder in. Make sure it's the right solder. You're not getting plumbing solder from Home Depot, and put that heat shrink over it. It really is still one of the the best, most solid connections out there compared to some of the alternatives that we've seen. And of course, with the butt connector, pretty similar, just without twisting the wires together, strip enough cable back, make that crimp, and then of course look out for excess solder that could be wicking out of it when you're done, but getting solder in is always a good idea. And with that, I actually want to turn it over to Larry for some of the higher amperage, larger gauge cables. Gets a little more fun to crimp those.
Yes, it does. When we talk about battery cable, it's basically anything 2 gauge and up, 4 gauge up, 6 gauge and up. But you're not going to use a set of traditional hand crimpers for any of these. And generally, most of this we're talking about either a battery lug or an eyelet lug that goes on it. Again, just like anything else, you got to use the right tools. The hand crimpers on the left, there's several different brands of them. There's some that do kind of a square crimp, some do more of a hex crimp. One of the things you got to be very careful of is make sure you're buying the right terminals to go with that set of crimpers. Again, some are very brand specific. Some of the other differences, whether it's a regular thin wall type lug, which I'm going to show you in a couple slides what that looks like. There's also lugs that are more of a die cast material. And the reason why is if you're not using the right brand to properly crimp a 2/0 lug, you may have to use the 1/0 setting because there's a difference in thickness of that wall. So you do have to be very careful using the right ones. Not cheap. There's different types, again, of shape they do. If they're set up right, hex versus the diameter square, about Ike and Mike, that if you do a proper crimp on them, it looks good. If like that terminal that we showed the cross section of, if you run a battery cable or a big cable crimp, do like a bandsaw, you should see very similar results where that copper is very compressed, fills in all the voids. And if you got a good pair of crimpers for that on big cable, generally you don't even need to solder. You do have to heat shrink, but you don't need to solder because you are dealing with enough mass there. One of the big things, again, the hand ones are great. They do make ones that are like a bench mount version. So you can use one hand to run the handle and then the other hand to hold it. On the far right there are some pretty cool pieces of equipment out there that are battery powered. Do some pretty nice crimps. Takes a little bit while for them to cycle. So they're not real fast, but they do a good job. And big thing, they're not cheap. But the one in the middle we do not recommend at all. It just does not give you a good crimp. If you do use one of those, 100% now I would tell you to solder it. But yeah, they just don't do a great crimp. Also, too, neither do screwdrivers, chisels, or concrete. And I'm joking, but I've seen people do all those things. That those are not proper crimps. And I'm amazed, too, at the number of installers, whether liftgate installers or inverter, things like that, that's, people that do this every day do not have a good set of crimpers. They're trying to use these, staking tools. So again, buy the right tools to do the job. Again, talking about a lot of the stuff from TMC and, specs out there for SAE. This is SAE J1127, but it tells you what all those ratings should be. Everything that we do is a GPT, which is a cross-link, which again has very high abrasion resistance, has 125 C temperature, very good resistance against chemicals. When I say chemicals, diesel, oil, anything that typically you're going to see in the shop. But the other thing you got to look at is general purpose versus more specialty, like welding cable. That's welding cable and regular cable really carry the same amount of electricity. They have the same amount of ampacity. The difference is flexibility. Same thing with a 4-gauge GPT or whatever. It has the same amount of copper in it. It's going to carry the same. It's that abrasion resistance, the thermal properties, all those things that make a huge difference what you're buying. And especially when you get into the big cable, most shops are not buying the right stuff. Next one to talk about is the terminals. Make sure you're using the right ones. Talked about before the bare copper. Yes, it's good copper, has a good connection, but they don't have the same corrosion resistance to take care of that. And make sure you got a good connection. And always make sure you're using the right wire gauge and also the right size hole in it. That you don't want to use a 1/2 inch lug eyelet and put it on a 3/8 battery stud. You got to get that surface area down to make a good connection. And actually, I went beyond my. No, I'm still in my spot. Trying to make sure I don't hog the screen today. Again, talked about before. Check the dies. Are you on the right ones? Yes, you can quote unquote crimp it, but boy, they sure look ugly, and you're not getting a good crimp if you don't have them set on the right ones. The right gauge, the right eyelet, solder. It's always going to be better. I will never complain that somebody wants to solder something. Again, heat it up after it's crimped. Let that solder soak in. One of the things I will tell you, because the amount of heat that it takes to get a lug hot enough for that solder to wick in properly, is do not get in a hurry and put your heat shrink on, because it is going to most likely over shrink or just completely melt because it's so hot. But when you're done, and you can see in the picture, if you look close, kind of a little bit of a ring at the end there, that is that dual wall where the adhesive or sealant is wicking out, totally sealing that connection for you. Another thing too is I highly recommend make sure your shop has red and black heat shrink. Not ever really going to tell anybody, hey, you need to spend the money to buy red and black cable, but make sure you're at least buying red and black heat shrink to identify those cables. As we get into higher voltage systems, it becomes more and more important. That's 12 volts has been the standard for years. We're seeing more 24 volts on trucks now. A lot of the add-on devices are 48 volts. So even when the new trucks, part of their new emissions has a 48 volt pump on it. So be very careful that, 12 volt sparks bad enough. When you start getting into 24, 36, 48, make sure you do everything you can to make ensure the right connections are going to be made. When to replace the cable, obviously severe corrosion. That's if they weren't done before, and sometimes the OEMs don't always do a good job of making cables. So if you see corrosion, cut it back. Make sure you can get back to a good clean cable. If it's green or black, generally green is corrosion, black is a wire's been overheated, usually because of corrosion, bad connection, whatever. But when a wire gets overly hot, it actually will turn black. Brittle cable insulation, a lot of times that's telling you that it wasn't the right insulation to begin with. It does not have a high enough temperature rating. So, my opinion, don't try to replace that or fix it. How to replace that cable and make sure you're using the right one. Talked about replacing eyelets, but what if there's a damaged spot in the middle of the cable? My opinion, do not try to butt a big battery or alternator cable. That if it's been chafing on something and you've got green damage in the middle of it, you need to replace that entire cable. And one of those things, talked about before, how long it takes to do a cable change out on most modern vehicles because of all the clamps and cables and all, and wire ties, whatever. It's all there for a reason. That if the manufacturer thought they could, scrimp and not put this bracket on or this retainer or this clamp or this clip or whatever, they wouldn't have done it. So it's all there for a reason. And generally when you start seeing damage in the middle of a cable, is somebody didn't properly secure it again. They changed the starter and, cut wire ties or took it out of a clamp or something and it didn't get put back in. And that's where you're going to get your damage. Corrosion cable, again, same thing as we just talked about. That is here in Arkansas, we don't use a whole lot of rock salt or anything on the roads because we generally don't get winter. Every now and then they will do some. That corrosion's bad enough, but poor fleets that operate in the far north, uh, that's not only you got rock salt, you got mag chloride, you got sodium chloride, you got beet juice. End of the day, you wind up with quite the chemical cocktail on a vehicle, and it's going to greatly accelerate that corrosion. We talked before. We have a salt spray test. Is I'm not even sure there's a hour in a salt spray test. Maybe only like 5 minutes of the chemical cocktail corrosion that can happen in some of the places up north. But anywhere you get into that corrosion, it's going to cause you voltage drop. Voltage drop is your biggest killer of starters. Starters can crank an engine gazillions of times, but you start impacting its ability to crank because of voltage drop, it's going to greatly shorten that starter's life. Same rule applies for anything. We talk about lift gates, and making sure the batteries are charged. Well, that has a huge impact on the life of the batteries, but also has a huge impact on every electrical device that's on that lift gate. Solenoids, valves, toggle switches, all those things. The lower the voltage, the higher the current, the more damage can be done every time that's uh, unit is activated or used. So I'm going to take one of the poll questions now. When selecting the proper wire insulation, why is selecting the proper wire insulation important? We've got A, chemical protection, B, abrasion protecting, C, temperature rating, or D, all the above. A little slower on responding now. I don't know if that's because of me or people are falling asleep.
I've seen them trickle in. Yep, here they
Yeah, there they go.
coming in like you open the floodgates.
Give us a couple more seconds. All right, we're above 50% response, so let's see. Perfect answer by everybody. Yes, every one of those things is very important when you're selecting them.
Yeah, and before moving on, Larry, it looks like there's a question in the chat on if you ever see a small amount of green corrosion, can it effectively be cleaned and prevented from re-corroding? Thoughts on that?
One, it depends where it is. If it's you're cutting off an end and there's some, that's part of the reason why we use flux. That can neutralize some of that corrosion and make sure you're getting a good clean connection again for soldering. There are obviously, just like we use for batteries, we got battery cleaner. All that is, it's kind of like the pouring soda on the battery to neutralize the acid. All those things are doing the same thing and trying to clean it. But yes, if you can neutralize, if it did come from acid or whatever, make sure it's clean, flux it, solder it. Again, trying to answer that question on a very open-ended scenario. But yes, it is possible. But if in doubt, yeah, cut it off, replace it, make sure.
Excellent. Thanks, Larry. And I believe it's rolling into a little bit of a last section here as we wrap up of, I think this is me. I'll take this.
Yeah.
All right. Well, thanks, Larry, for all the info on the battery crimps. Really good stuff. And we'll keep it a little bit brief on the end. Still some pretty important stuff. Just like Larry said, if you are replacing a cable, make sure that you know that cable's path. And the biggest thing, if the OEM had a wire routing path, there's probably a reason for that. If they could save a penny by not putting a clamp in one place, they would. But having cables routed properly is huge, huge, huge in preventing shorts or abrasion through the wire jacketing. So, of course, looking out for any sharp edges and not having lengths of excess cable laying around once you're done with the install. Um, too tight is not always right. I like that. And just making sure that the path that cable's taking is clear of debris. We've certainly seen a number of brand new trailers where they were running cables through cross members and just sharp edges. That's going to work fine for a few months, a few years probably, and then it's going to turn into a bunch of phantom issues. Hey, we didn't do anything different with this trailer, and now we're having all these issues. Uh, I know that we all trace down issues to seeing a cable that's been chafed through. So making sure that that cable routing is correct is a huge part of proper wire repair. And the extra step on all this, the high current cables, uh, again, watching out for abrasion, making sure that they're in conduit if it's going to be in a spot that could be exposed. And exposed cables, you certainly want to use conduit. And in-cab routing certainly helps to avoid a lot of the elemental concerns on these cables, but you also have to be careful on what else is around that inside of the cab. And biggest thing, routing your wires away from potential damage. One of our harnesses for liftgate charging, occasionally it will utilize the reefer for battery charging. And some of these reefer engine bays, you have belts running around, hot parts. Making sure that the wires are routed properly is huge in making sure that it's going to be a reliable connection. And testing the repair, of course, the physical examination of just looking at it, making sure that, like we said, it's routed properly. You don't have cable loose hanging around. It's away from any chafing points. And functionally, is the repaired circuit going to carry the original current and deliver the correct amount of voltage? Voltage drop is a very, very real thing. You could check voltage at your starter motor with just a paper clip running from your battery to the starter with nothing else. You're going to see 12 volts there, but the second that you try to run current through that paper clip, voltage is going to drop almost to nothing, and you're going to have a very, very hot paper clip. And again, just the pull test on the connections to make sure that you're good there and that all of your connections are sealed at the end of the day. And circling back to voltage drop, if there's no load on that, you're not going to see voltage drop. You have to have a load on the circuit to measure voltage drop. And right here is a great, very generalized measurement of voltage drop, but that's really all that's happening when you're measuring voltage drop is a voltmeter with you might need some lead extensions, but going from the source of that power to the load on the other end of that wire, and making sure that if you do have voltage drop, it's within an acceptable range. TMC has some recommended practices around this, and if you don't know, then check the manufacturer, but realistically, you should always be aiming for little to no voltage drop, especially if it's a lower amperage device. And from there, I think that we are rolling into the next poll question. To properly test or repair, the circuit should be A, tested with an ohm meter, B, tested under load, C, checked with a test light, or D, loaded until the smoke comes out. Who wrote this?
I might have had something to do with
it. We'll get some answers in on this poll question here, and then we'll have some extra resources after this to wrap up. But let's wrangle up a couple responses on this on how to properly test the repair after it's been made. You guys have all been a very responsive audience on these poll questions here and with the questions, so thank you for that. This has been a great webinar and definitely one of the more important ones. You're not getting away from wires in the trailer industry, so making sure that things are done correctly is huge, and being here shows your commitment to that. And I think that we got a pretty good amount of responses here. We'll get the answers, see what people answered on this poll. There we go. Tested under load. That is the answer. The ohm meter was a little bit of a maybe a red herring there, I would say, right, Larry? Really, it should say
Yeah.
a voltmeter testing for voltage drop.
Well, no, people will try to use an ohm meter, and the problem is an ohm meter doesn't have enough resolution, or it's got enough resolution, but it just have the capacity to read resistance low enough to properly test one. So you're getting into thousands of an ohm for what the resistance would be for some of these. Even a battery cable that's right, the resistance is 0.000075 ohms, I believe. If you try to use an ohm meter, that's why we have to do a voltage drop check, because an ohm meter can't read low enough to do it.
Excellent. Great clarification. I'm actually going to turn it over to you to kind of list out a couple more of the resources that would be great for anyone interested.
All right, and I'll try to go through these fairly quick, but we are worried about being done too fast, and we've gone overtime. But different blogs, different webinars, things we've done before. These are all links, and again, tomorrow you'll get a link to this. There's a lot of the stuff in the resources already that you can click on. But buying the right wire, how to make a good crimp, preventing water intrusion. Talking about all the TMC RPs. This is, again, only a partial list of the electrical RPs that are out there. And keep in mind, there's two different types of RPs. There's maintenance RPs and there's engineering RPs. That if you're not familiar with the two different lists, so wait a minute, I can't find this one. Oh, go look at the other one. But these all have wiring recommendations one way or the other, whether it's wiring solar panels or voltage drop of cables, selecting the right wire, wire repair guidelines. Here goes into the engineering ones. The one we talked about before was 105D, design and installation. So if you are going to add a device to your fleet, hey, we're going to put new backup lights on the back of the cab for our trucks. Well, that's a good starting point of, what do I need to look at? What do I need to, make sure I'm aware of before we make that and find out, oops, I used the wrong type of wire. I didn't use big enough wire or whatever. Then, some of the last ones. But again, if, your company is a member of TMC, these are all available on TMC Connect, where you can go back through and look at them. If you don't, you have questions, please don't ask me to, email you the entire thing, because it's 6,000 pages. But there is some very good information on here. And we don't want you to hang up yet. Are we hanging up? What webinar? Don't leave the webinar yet. There's always some follow-up questions. We're trying to do a survey. One is, was this helpful to you? But some of the other things just in the chat, if you would. Anything that we can do to support you to help. Some of these are salesy, but a lot of these we try to do as a way to give back to the industry. How can we support other people out there in the trucking world, and also how to support our products. So please don't hesitate to chime in and send some of that. And I'm going to let Tim send us out of here.
Yeah, pretty well wraps it up. At this point, Larry and I will hang around a little bit. If anyone wants to chat some questions, we can get a little bit of an open discussion. It looks like the audience here did a great job of bringing up some questions throughout the webinar. Thank you guys for the engagement here. We'll hang around for just a minute for any questions, see if anything comes in. But this is certainly one of my favorite topics here, just the amount of times that can only imagine the amount of times you've been in the field having to diagnose and troubleshoot some wire issues, Larry. My 3 years at Purkeys, it's certainly been a little bit for me myself as well.
Oh yeah, and all the pictures, are years of being in the field looking at all this stuff, and it's amazing the things you will find. And one of the things that's pretty interesting as we talk about higher voltages, some of the new trucks right now are 24 volts. cranking and charging. That as you raise the voltage, everybody wants to do that because if I can double the voltage, I can cut my current in half. So a lot of people look at it and says, ooh, if we did that, all of our wire could be smaller. That saves weight, saves money, all these great things. The thing people forget is when you raise the voltage, corrosion happens. I can't remember how much faster, but bottom line is if you go from a 12-volt system to a 24, if you do have contaminants, acid, rock salt, whatever, your corrosion will happen much faster. So when you get 36, 48, you get to the point you can almost watch stuff, turn green. And one of the products that Tim works with a lot right now is one of our products called SafeX, where we're using 480 volts for reefers to be able to run on shore power. And can you imagine how fast corrosion can happen with 480 volts?
Yeah, I think the wire repair fundamentals will become more and more important, more than it already is with some of the basic stuff that we have out now. All right. Well, I haven't seen any other questions roll in.
Nope. What? Celia, turn it over to the survey.
Well, thank you guys for joining.